In this video, we're going to take a look at some superclass and subclass best practices. In other words, extending a class in Java. So first of all, what's the case for extension? Well, a lot of times we have a case where we want a common behavior among a lot of things, but then some things need their own special behavior. And a good example from real life that I can give you on this is when I worked in the point-of-sale software industry. We had the company still exists, has a product that is customizable by retailers. And that's important because you think point of sale, oh, they're all the same. No, not really. Retailers have their own business practices that they need to implement. And even in industries, there are certain practices that are common among competitors within one industry. The company I worked for did a lot of work in pharmacy. And there were certain restrictions around things like pseudoephedrine that pharmacies had to have baked into the point of sale. So they offered a point of sale product and then said, oh, by the way, you can extend this and add your own best practice to it. And for 10 years, I'll say it was 10 fun years, my job was to go to these companies and train them on how to extend the point of sale to implement their own requirements. So that's the business case for extension. Now, one thing we want to think about as programmers is how do we know if we're doing a good job with object-oriented design? And you might be surprised at my answer here because I was equally surprised when I heard it. Back around 2000, 2001, I took training from directly from Sun Microsystems, who at the time owned the Java programming language. And the instructor told me something that really changed my outlook on object-oriented programming, period. And that is, number one, if you're not using interfaces, you're only using half of Java's potential. We'll save that conversation for a future lecture. But number two, this is the one that surprised me. You can judge the quality of object-oriented design by counting the if tests. The fewer if tests, the better. And I thought, okay, now that's weird, because I use if tests all the time. Why are they bad? And I didn't ask. I thought, I want to figure this one out on my own. After about 9 months, both of the things he said to me really clicked. The short version on if tests is that if tests often indicate that you're doing different behavior in one class. And instead of having different behavior in one class, you should have unique behavior in each class that represents that behavior. And so that's essentially extension, subclassing, which is what we're talking about right now. Now, why do we need extension, and how does extension work? Well, here's a fairly typical business case. So we have the concept of a vehicle. A vehicle goes a certain distance, the odometer increases, the gallons of gas decreases. Okay, there we go. Now, if we have a Chevy Sonic, well, a Chevy Sonic or an Aveo, whatever, a simple car, is a vehicle. And it does basic vehicle stuff. It's, a very simple vehicle. It goes. Okay, easy enough. Things get a little bit trickier, though, when we look at our other cases. What about a Mustang? A Mustang has a lot more options, including convertible. So, well, we could go up in our vehicle class and add an if test and say if it's a Mustang, then allow a convertible. But we know that if tests are oftentimes things we want to shy away from because they indicate that logic is in the wrong place, that we should be using a subclass instead of using a whole bunch of if tests. So for a Mustang, we're simply going to extend the vehicle and add that special attribute of convertible. Now, the case that gets really tricky is when we have something like a Prius, which is a hybrid vehicle that can either run on gas or electricity. So the odometer is always increasing, but the gallons of gas is not always decreasing, and sometimes the battery charge is increasing. So a little different behavior there. So here we have a Prius, and we have some special rules around when to use gas and when to use electricity. So if the charge is less than 5, use gas. If the charge is greater than 5, use electricity. Something like that, but we also want to consider the case of the odometer increasing, the gallons of gas not decreasing, the electricity increasing, all kinds of iterations around that. See, here's how we would describe that in a UML diagram. We'd start with a vehicle superclass that has a go method. We would extend that into our Sonic or our Aveo, whatever our simple car is. No changes needed. We add our Mustang, but to the Mustang we're going to add another attribute about convertible, which I don't have on this chart, but you get the idea. We add our Prius, and we say, oh, wait a minute. Prius has special behavior, so we're going to override the go method and provide that special behavior in the Prius. And if necessary, we can still use something called super to call the behavior from the superclass. Now, as we get into inheritance and extension, we get into some of the absolute most fundamental principles of object-oriented design. I learned API when I learned object-oriented development, and I'll call out the ones that apply most specifically to extension and inheritance. So abstraction, show only what is essential, hide what's unnecessary. That's a good idea in general, not necessarily directly related to extension, although we do have this concept of abstract classes, which is closely related. That's a topic we can get into a little bit later. Polymorphism, super important one, and in polymorphism we have to be comfortable with the concept that a variable type and an object type can be different. They must be related, but they can be different. And by that I mean this construction we see here, vehicle equals new Prius. Now let's break this down. What is vehicle with an uppercase V and then vehicle with a lowercase v? That's declaring a variable. Now what is new? That indicates we're invoking a constructor. A constructor has the same name as the class itself. So here we're saying new Prius. So we're taking a Prius object and we're putting it into a vehicle data type. That will help us understand polymorphism, because polymorphism says the variable type tells you what methods you're allowed to call. The object type tells you what will happen when you call those methods. Indeed, a variable type only needs to be a list of methods, which essentially is an interface. The behavior is only important for the object type. And you can kind of visualize this with vehicle and Prius, because we can think that a lot of vehicles are internal combustion, but a Prius is a hybrid, so it has a little different behavior. So we want to inherit what we can from the vehicle, but we also want to have a subclass for Prius where we can override things that are specific to the Prius. Inheritance, I pretty much just mentioned that one. So if we have the concept called vehicle and the subclass called Prius, the subclass called Prius can inherit anything that is not private from its superclass. And then it has the option of overriding certain methods and also adding additional functionality. So polymorphism inheritance, absolutely central to this concept of extension. And then encapsulation, well, that's one that's not really related to superclass, subclass, or extension. That just means keep data and variables private and expose what you want to expose through getters and setters. So that's a lot of times how I think about object-oriented programming. One thing that we hear a bit more about today is the concept of solid. So one of these terms we've already explored, which is single responsibility. A class should only have one job and only have one reason to change. That's not directly related to extending classes, but it is somewhat related, because we want to think that we have a vehicle class that represents, what we commonly expect out of a vehicle. But then we want another class that has the Prius specificness to it, and the Chevy Sonic specificness to it, and the Chevy Bolt specificness to it, so on and so forth. So each class has its own purpose. So definitely something we use, although it's not always related to subclass, superclass. Open, close, though, that definitely is. So classes should be open for extension, closed for modification. So if we want to handle a Prius, what we don't want to do is go in and change that vehicle superclass, because then what we're going to end up with is a bunch of if tests. And we know that if tests are sometimes necessary, but excessive if tests are a big sign of object-oriented design gone wrong, or in other words, implemented incorrectly. And they also make unit testing hard. They make code brittle, makes it hard to change, hard to maintain, hard to update. So open for extension, closed for modification means you can subclass it, but you don't want to change the internals of the class itself. You'd rather override it. Liskov Substitution. Every class should be substitutable for its base class. That goes back to our example from the previous slide, where we have a vehicle, but we can substitute in a Prius for that. And if we are extending vehicle into Sonic, into Chevy Bolt, into all of these other things in a Ford Mustang, all of those are substitutable for the superclass. Interface segregation, we're not going to cover that one just yet because we need to understand what interfaces are. But dependency inversion is actually closely related to Liskov substitution as well. And what that means is when we have our abstraction up here and we have some concrete classes down here, anything that needs to deal with a vehicle should deal with the abstract type at the top, the vehicle. It shouldn't deal with those subclasses unless it's absolutely necessary for some reason. But to summarize, If you're making a Sonic, a Mustang, or a Prius, and you're doing this in another class, maybe some kind of verb class or some kind of worker class, store it in a variable of type vehicle. Here are some important terms we want to keep in mind when we're talking about extending a class. So first of all, a subclass extends a superclass. When you declare a class, you say public void foo extends bar. That's how you indicate that relationship. Now we know access modifiers, and so far we've used things like public and private, especially in the case of encapsulation, where we keep variables private, but then we expose them through public getters and setter methods. Well, guess what? We get to introduce a new access modifier, which is protected. And protected means that I'm not available to the outside world, however, I am available to my subclasses. So it's a little more than private, a little less than public. You have to be a subclass to get access to this variable or this method. Now, overrides. So we can have a method in a superclass, let's say public void go in distance. And we can have a method with that exact same signature in the subclass. And in that case, it's called overriding, because the subclass is overriding the behavior from the superclass. One important note there, though, you want to do that with, more than likely, with the access modifier that we just learned, protected, maybe public, but you don't want to do it with private. If you do it with private, you get into a situation where you're not actually overriding. You have a shadow condition, and that can lead to some very curious bugs when you don't know why one method's getting called and not another. So be careful with that. Also be careful with the word override. Don't confuse it with overload. So override means we have a method in the subclass with the same signature as the method in the superclass. Overload is similar and unfortunately sounds very similar. Overload means we have two methods with the same name but a different parameter list, usually in the same class, although they can be in different classes. That's an interview question. Someone will ask you the difference between overriding and overloading. Just make sure you have those two separate, and it's really easy to get them confused. Now, let's say you are in an overridden method and you want to call a superclass method. Well, then you can use the keyword super, open and close paren, pass in the arguments you want, and that will call that superclass method. This also works in constructors. Dynamic binding is probably one of the more confusing topics to understand, and I have a video that goes through that specifically in code with the debugger. Dynamic binding means I'm in a subclass, let's say foo. It extends a superclass called bar. We override a method from bar, we'll say go, okay? But that method is invoked from another method in bar that we're not overriding, but instead we're inheriting. And let's say that method is start. So inheriting start from our superclass. Start invokes go from the superclass, but we're overriding go in our subclass. So when start invokes go, which one gets called? The one in the superclass or the one in the subclass? Well, if we instantiated an object of the subclass, then the overridden method will be the one that gets invoked in that case, and that's what we call dynamic binding. Very important concept, hard to explain in words, much easier to see in demo, which is why I encourage you to take a look at the debugger demo that I did there. So in this video, we've seen some super and subclass best practices about extending classes in Java. These apply to most object-oriented languages as well. As always, I hope this video was helpful, and I look forward to reading your comments. Thank you.